thing, I invite you to subscribe, and I hope you like it well. Let's change. And as I was saying, let's start with functional groups. Functional groups. These functional groups that we're going to see are functional groups that do you have in order, just like the nomenclature, which you have other videos that you will make for me on nomenclature. And as I told you, why are these functional groups going to be important? Always in these videos, we are going to talk about the importance of these, for example, these functional groups, but relating them, for example, to pharmaceutical chemistry, to biological chemistry, to compound chemistry simply, for example, for the environment, toxicity, etc., etc. Well, let's see. The first compounds that we are going to see, and as I said that we were going to see with respect to the functional groups, here you have the priority table. Let's look at the cations, and within the cations, the ammonium. Well, as you know, in organic chemistry, compounds play according to their valencies. In the case of nitrogen, we would have 3 valences and a couple of unshared stars, and in this case, it would be a mine. Good. Carbon plays with 4 legs, oxygen usually with 2 legs, 2 unshared chips, halogens with 1 leg, and different unshared parts. Well, we're going to see all this. As we were saying, let's start with ammoniums, with ammonium compounds that are cations. These compounds have the highest priority in nomenclature, and if a nitrogen, we said it had 3 valences. It would be a mine, a primary, secondary, or tertiary mine. What is it? What is an ammonium? An ammonium is that we have a dative bond with this pair of electrons in which it is attached to another radical, and we can have 2 types of ammoniums that can be fixed salts, in which we have 4 radicals, alkyls, garols, or different nature, and where we have a salt that has a counter ion, that this X can be therefore halogens, fluorine, chlorine, bromine, iodine, that you are used to seeing like this, but they can be others, such as sulfonates, toxylates, different salts that we will see during different videos. Okay, and this is what a fixed salt would be. Evidently, a salt is telling me it has charges, then obviously it's going to depend on the radicals we have here, its solubility, but in the end we're playing with a lipophilicity, we're playing with a hydrophilicity, etc., etc. And then there are other types of salts that I put in another color, which would be the labile salts. What is a labile salt? Well, where one of the radicals is no longer an alkyl or an anyl, but is a good hydrogen. These salts are labile salts, not fixed salts. Why? Because these salts, depending on the P, K, or A of the conjugate acid, the pKub of the base, are either going to be ionized or non-ionized in amine form or in not ammonium form. Well then, these salts that are fixed will have characteristics, and they will not be able to pass easily to mines, but they can pass, well, some dealkylation reaction, either chemically in a laboratory or either in. At a biological level that can be produced, however, these salts that are labile salts are reversible salts, and depending as the pKs A and the pH famous equation of Henderson-Jaserva told you, because we are going to have it, will be unlimited or not irradiated according to. Well, let's look at some examples of these quaternary ammonium salts, fixed and non-fixed in drugs. Well, the first thing I tell you is these drugs, obviously, to see functional groups, well, I will put some simpler ones. We will do exercises. I will give you examples, but obviously there will be some compounds that may be a little more difficult at the university level, but hey, whoever they serve you are welcome to agree. Well, first thing, I give you one simpler, which is a benzalkonium club, a benzalkonium chloride, which is an ammonium, which has a benzyl group, which is this year aromatic, which I will now talk to you about, 2 methyls, and a large alkyl chain. Of 12 carbons, a dodecane, 93 C7 in Napole 11, and 12. Okay, this one would be left over. I'm going to delete it. Well, he did it to you like that, and that's fine. As you can see here, we would have a benzalkonium chloride, positive charge, negative charge, and we would have a salt. This benzalkonium chloride can be used as an antiseptic, as an emulsifier. Realize that these ammoniums can have 2 characteristics, characteristic of polarity due to ammonium, also depending more polarity or not, depending on the groups you have, and lipophilicity due to others. Therefore, it can be used as an emulsifier, and has amphiphilic type characteristics, it has no affinity. On the one hand, on the polar part, such as soaps can be, for example, and on the lipid part, as I said, it has a chain of 12, in this case dodecaine. They change as antiseptics are used, as I said, for example, oral antiseptics to clean surfaces, because in hospitals and so on, we have a benzyl, with which here we have a group that is aromatic damage, and we have salt well. What else do we have? Well, come on, I've put here the neurotransmitter acetylcholine from the parasympathetic nervous system, the autonomic nervous system. It can be a sympathetic nervous system where you have an adrenaline that, as you know, that the adrenaline it will activate increases the heart rate, and heart rate. The heart of the heart vessel constriction and bronchodilation, adrenaline, noradrenaline are activated when there is a state of fear, when we have a state of danger, when we see the boy or girl we like, when we have to speak in public. In this case, I have the sympathetic very activated, okay, and then the heart is faster, the bronchus of hydration. Because obviously if we see the boy, the girl we like, we will run, okay, base. Time if they stab us to avoid bleeding, and as I said, for hydration to run, right? Well, and the parasympathetic nervous system, what is acetylcholine that, as I tell you, has an ammonium group? I paint it here. It would be an ammonium. This is a positive charge. Well, I painted a little wrong. I'm going to erase it like this, and I paint it again. It's worth a positive charge. I paint it well. Which will be with a chloride, with a bromide, and then it has a group of this type, methylcholine being an ammonium, since they are already telling us that they are going to be compounds that are going to have, in principle, an important hydrophilic polarity. This makes the compounds, from the point of view of drugs, pharmacokinetics, we will have problems in absorption, for example drugs, and it will be orally. We could give it acetylcholine from other days. The problem it has is that it has mycotinic recipes in muscarinic ones. So it has quite a few side effects and is also quickly degraded by esterase. I can only use acetylcholine as a drug, or I use it at a local level. In very few cases, for example, for a very specific cataract operation or something like that, not at a general level. Well, however, we have a drug here because the parasympathetic cholinergic system, we have many drugs with the ammonium structure. And here we have, for example, betanicol, which would be a similar structure. We would have, well, then I turn around. The eastern one has a methyl in beta that makes it more muscarinic, effective, okay, that's a methyl. And then it has what would be the same ammonium. And another very important change that has not been painted is that he is a good Karmamato. All this makes him more selective for muscarinic actors and have a longer half-life, that too. I'll explain it in pharmacology, chemistry, pharmacy, etc., etc. in other videos, and as I told you, important functional groups, because here we have ammonium and here we have an ester as a functional group, an ester, and here we have a carbamate, which is a compound where it has an ester and an amide at the same time. That's called carbamate well, and it also has love. Okay, we would move on to see a subsinylcholine or susamethonium. I am going to delete this part to see what I do with this system, which is my first video with this system. So if I have errors, I hope you will forgive me. Well, I do them in a row, as always. If you know me or you don't know me, well, as you know, I make the videos all at once, and normally I paint all the molecules for you because I kind of know. Let's go to a succinylcholine. As I was saying, the entire cholinergic system has many ammoniums. He painted us all, but for example, we can talk about an atropine, a scopolamine, a pancuronium, etc., etc. Succinylcholine is a neuromuscular antagonist, used, for example, for anesthesia, a neuromuscular bleaching, depolarizing, and succinylcholine. What structure would it have? Well, these drugs are characterized by having two ammoniums at a certain distance. Here we would have a hill that comes with the succinic that we have here, and then in this case it is completely symmetrical. Another ammonium is worth, and in these cases the distances could change to a black color of the two ammoniums is crucial to have that nicotinic type polyergic rector blocking mechanism of neuromuscular plate well. Among the pharmacophore group, you see that I have an ammonium, and I have two groups of this type. That would be the pharmacophore groups. And finally, I have put here muscarine, another muscarinic agonist of natural origin, where at the beginning of the video, you have seen a capsule of mine with a muscarine. Well, because it has Amanita muscaria, be careful. It is toxic, obviously, because it also has this ammonium type structure. This ammonium here is important. The astrochemistry of these centers is important. Let's see that it has been erased from me. It has an ammonium. It has 1 or H. Here I'll give you another sterogenic center that we'll talk about over several videos. And here it has a methyl. In this case that we have as pharmacophore groups, we have ammonium, we have an alcohol, we have an alcohol, we have an ether. Notice the difference between an ester and an ether. Well, all important for their mechanisms of drug action. Okay, I have these examples here that I have painted so that we can see them again sometimes, or I will paint them one way because I know it one way, and in other cases they will appear another. But will they be the same compounds? If I am wrong, I will say it, because since we talked about peticoline, pharmacophore group, important group, functional group, an ammonium and an ester, betanicol. Well, it has been changed to a carbamate that is called at the same time, and succinylcholine also has an amino acid because, as has been said, it has ammonium and it has ester groups. Well, muscarine has an alcohol, an ether, and an ammonium functional group, and benzalkonium, which is the first one to put benzalkonium's as because it has an ammonium. An aromatic, which is important from the point of view of conjugation and aromaticity. That is, it is a functional group and a 15 chain. Okay, well, given this, we're going to see some molecule exercises to identify the following functional groups. As I tell you in all the videos, I am going to give you examples, exercises, and so on. Well, the first one we have given you is a hydrophonium. What is an inhibitor also belongs to the system. Parasympathetic echolinergic is an acetylesterase inhibitor, a reversible inhibitor. Acetylesterase inhibitors are very beautiful organophosphorus carbamates, we will see. And hydrophonium has a phenol. And then here it has ammonium. Okay? Well, this ammonium is an ammonium. Very simple, phenol and ammonium, and is used for is an antoxtopiaceous because it inhibits forgiveness. Antagonist of acertric and esterase. I have switched to methyl in the person who now paints it, which if it is yes, it is an antoxtopiaceous. And if it restylizes, because if it restylizes due to non-union, reversible forgiveness. And we have said that this drug can be used, for example, to diagnose a disease called free myasthenia, which I will talk to you about at another time. Okay? D-tubocularine, this drug really appeals to me. It amazes me a lot because it is a compound of natural origin. The Indians to hunt, that what they did is a neuromuscular relaxant. What it does is block the nicotinic receptor at the level of the neuromuscular plate, just like we have seen succinylcholine before. And from this D-tubocuranin, by simpler variations, derive drugs such as sultinoline, which has been painted above, and many others. Okay, but look, the structure so interesting that it has so complicated has an isoquinoline. I paint it here. I hope to paint it well that it has an ammonium. It is a derivative of tetrahydroisoquinoline. It is not totally aromatic, and then it has a part that is quite an ether around here, a fairly symmetrical alcohol, completely symmetrical. Here you have a phenol, and I go to this side of here, nothing happens, and in Paradino, a methyl, and here you have another isoquinoline, which is fine, but this isoquinoline is not ionized, and then here you have a benzyl again. That meta is attached to an ether here. Here has one H and one CH3. I hope I haven't painted it wrong, then it appears. So well, there you have it. Notice that the importance here, we are talking about an ammonium. Here we have a positive ammonium because it is quaternary. That is attached to 4 radicals, well, but this one is not. But nevertheless, I do need 2 ammoniums. What's going on? Well, here you have a tertiary mine that what it is going to do is propose itself to physiological pH. It's a reversible room, but it generates live ammonia, and then that's when it blocks the receiver, right? Well, other groups that we would have in this molecule, because they are ethers, phenols, alcohols, ethers. There we have again an ether, aromatic rings of ethanoline, an alcohol, an ether. Okay, then we have it out there again, painted well. Methyl-latresone or Pinto, here methyl-latresone. If you don't like opiates, then it has a characteristic opiate structure that are morphines, which is a complicated structure. Veil from Papa versiniferum, since we have these three cycles, we have a deposit ring, we have a phenol veil, and here a 6 ring of the piperidine type, and with a typical antagonist radical such as nalosone, the alterone, this propimethyl cycle. And then an H in 14 that we can see painted in other ways. And here the classic ketone that gives it more lipophilicity. For example, psychodones isohouse, because this structure is good and it is an ammonium that, as ammonium is not going to cross, it is not going to be absorbed, it is not going to cross the brain neighborhood, and we are not going to have the opiate effect that we could have at the central level, which these drugs, since they are quite complicated to handle, always have to be handled carefully with a prescription, etc., because of the effects it has. In this case, since it is not absorbed because it is a salt, it has an effect at a digestive level. And in this case, it is counteracting. Will it be with opioids to avoid severe constipation? A side effect that opioids have, okay? Well, what else do we have? Propranolol, a beta blocker, and a supposed propranolol clydate. That is a drug, a compound that is not an ammonium, which is amine, as we'll see now. Has this naphthalene, has this. Better an alcohol, and this NH with an isopropylene. Okay, so what we do, or what is done many times, is that many compounds, drugs or compounds, are usually oils. An oil is very difficult to handle. I couldn't handle it well. Imagine, for example, if I have to dose it into a medicine, a dose. This beta-adrenergic blocking drug, beta-1, beta-2, because it is not selective, but for the heart, antiarrhythmic, antiaginal, antihypertensive, has many other actions. But imagine that the dose was an oil, not a honey. I couldn't dose it. So many times what I do is an ammonium, making a salt, I put numatrol in it, I pass a current of hydrochloride, and what we are going to have is a salt because the amino, that is basic, is going to take this proton. And well, I don't paint it whole, I paint it like this. And what we would have would be a labile quaternary salt. And as you know, this is a positive. Okay, we would have a balance between the ammonium form or the amine form, and then by making this ammonium hydrochloride, as I was telling you, I can already dose it, and I can also increase its solubility. These ammoniums increase the solubility, the hydrosolubility, therefore I can give it in an injectable in a syrup, or it can simply crystallize into a solid. And also for it to be absorbed, it has to dissolve, thereby increasing the solubility. We make it better absorption. Okay? Well, all those concepts we'll talk about in other videos. Well then, as the propranolol said in principle, well, now as I have them later, I'll tell you the functional groups. Okay, well, here you have some of those that were painted. As the methyl said, in the person we would have an ammonium. This propyl methyl cycle that I have told you, that is an antagonistic point, the OH that I have painted before upwards for the same reason upwards. According to this ring, it is painted downwards upwards, but I don't care. With which this would be an alcohol, functional groups, alcohol, another alcohol, which in this case is a phenol, because it has the aromatic child. They are alcohols a little different. They have different characteristics. Fix this ether type structure in that, forming a similar cycle just like morphine. And here we would have an acetone, a ketone. These would be a little bit the functional groups of this drug, that of tubocuranin, as I told you that it has an ammonium, and here it would be a mine, in this case a tertiary mine, which is basic, and that is protonated. As I told you before, we would have an ether, an alcohol, another phenolic ether, another alcohol, another phenolic ether, and another ether. Here I have told you that it was a molecule that was very, very, very beautiful, because it seems that it is not completely symmetrical, and as I said, well, to hunt in different types of the Amazon jungle, well, what it does is that with some arrows they shoot, them are impressed by tucularin. Look at you as if by chance they get the poison to swallow it, nothing happens to them, because since they are ammonium, they will not be absorbed, and therefore I do not have that side effect, or when I eat. The food of that animal that I have hunted, even if it has D-tubocularin, would not affect me orally, okay? But obviously if I use it as a relaxant, a muscle, anesthesia or something else, I will give it orally, otherwise I'm not going to inject it. Furthermore, these drugs have to have special control. Well, what I told you before, propranolol color halate, since I make the ammonium salt and it is a label salt, it is in equilibrium according to pKs A and pH. Well, it will be ionized or not. In this case, it would be amine, a secondary amine, a secondary alcohol, and an ether and a naphthalene as an aromatic child. And then it would happen when you protonate an ammonium salt, which, as I told you, is to make the salts many times to solve into a drug, in injectable, in a syrup, or simply so that it is a solid, crystallize it, and you can dose it because this is an oil, and I can't dose it. It hasn't been painted before. Halodipine mexylate. Okay, you have it here, and here we have the gap, but I haven't painted it, okay? I'm going to delete a little bit because I like to paint them, okay? I'll delete it here. Well, as I tell you, I am also getting used to this new system, and I hope it turns out well, okay? Halodipine is a 1,4 derivative of hylopyridines that has this structure, okay? This structure, halodipine has a chlorine here, they are in amines, here we have an ester, here we have another ester, and here we have an ether with an amino group with which I make the salt in H21, primary amine here, a hydrogen. Good, these drugs. I really like them because I call them little birds, little turtles. Now I tell you about it. Well, with this mino-alodipine mexylate, I would make a salt exactly the same as before. A salt the same as propranolol chlorhalate. I make a salt, but I do it with a mexylate, which is this, so that you can see that I don't always make the salts with the same counter ions, not from sulfonic methane. I make a salt that would be a salt. Hey, although it comes from a primary mine, and what I said, well, a salt, so that it crystallizes, so that they can administer it in other ways, so that its absorption improves, etc., etc. Well, as I said, these are very pretty because they are little birds with a little pike, an eye, a little body, a little wing, another a little leg, another little leg, the tail, one and the other. Well, it looks like a little bird, it's erased from me now, but there you have it, okay? And here you have it. It is not in the form of a salt, as we would say, as I told you before, because this would have a positive charge if it is ammonium. Careful, because before it was an ammonium, what we had here, or I deleted it here, as functional groups. What would we have? Well, as functional groups, we would have amine, but it is conjugated with a double bond. This system is called enamine-enamine. Here it would also be self-enamine and ester, an ester. An aromatic ring, and then over here we have an ether and a primary mine with which we have made the salt. Alright? Well, that's all. So far, this video, I hope you liked it and nothing. I hope you follow me in these videos. Like, please subscribe and nothing. Anything I like to help, so welcome. I will continue recording some videos, and I hope that, as I tell you, that they are useful to all of you who see them and follow me. Thank you very much, and see you next time.